sorry, but in America, competitive debate, at least the style that I specialized in, is a full year-long topic, and the people who are arguing against each other talk really fast. And the reason for this is that if a piece of evidence that one team argues for is not brought up by the other team, they will lose, or that argument will be accepted. And so this idea has sort of been gamified to the point where debaters speed talk with the intention of the other team losing something. I'm only bringing this up because it will give you all context for why the data sets that I've created are so large, and where the kind of source of my love of argument mining as well as natural language processing started, right? So circa 2017, actually circa 2014, I was one of those debaters, and I had to prepare thousands of pieces of evidence because it's a full year-long topic. And preparing that evidence is a challenging summarization task. And so I'm actually going to link a repo real quick to the chat where we can sort of talk about my first bit of work I did. So in the chat, I've linked it. It's called CX_debate, stands for cross-examination debate, the style I'm talking about. I wrote this, it's called a word-level queryable extractive summarizer because it summarizes documents in a way that debaters do, kind of like with a highlighter. And the reason I bring all this up is that currently, and at the time, the academic summarization world, right, the world of researchers who are trying to figure out how to create better summarization systems, is obsessed with selecting only the best sentences. It assumes that we humans perfectly, only highlight or underline full sentences in a document instead of like skipping around from one sentence to another. And this was a really weird, right? Because I've seen people even outside of the debate community who, summarize with a highlighter. And then I just had this moment where I'm like, why is academia not, studying this in a way similar to how we real people do it, right? And at this point, I'm not, even working for a tech company yet, and I'm not really an experienced researcher. And now that I have had some, experience at the kind of NLP conferences and publishing papers, I know the reason. And the reason is that real summarization is hard. And whenever things are so hard that they can't figure it out in academia, one thing that they like to do is simply make the problem easier. So I'll also point you all to a project from IBM called IBM Project Debater. They did a lot of this work kind of to create like AI systems that can win in debate rounds. I think it accumulated in like 2021 with their paper in Nature and being on the cover of Scientific American. And I'll real quick pull that up as well, just for a bit of context for anybody that wants to read more. I bring up Project Debater because the type of debate that they do, or that IBM did, looks nothing like debate in America does, right? It looks the way that you all might have imagined it, two people kind of on this podium talking slowly. But it was all just kind of a publicity stunt. And that's in the words of the Project Debater founder, Noam, who I actually got to speak to at EMNLP at the argument mining workshop. So, great work from them, but an example of kind of what I mean when I talk about how a lot of my research has been sort of focused on areas where the AI community deemed something so difficult that they just reformat it into a different problem. But this was sort of the motivation for me, right? I was, just getting my computer science degree, and then I realized, oh my gosh, I need, to get really good at systems that can summarize. And then I went deeper into natural language processing, and thus my passion was born. So I think the first lesson I want people in this room to take from this kind of webinar is that passion and love of what you're doing is extremely powerful and potent. And I'll admit, my first year of computer science education, I'd never programmed before, right? And programming's really difficult. I struggled my first year. I don't feel like I can say that I actually knew how to program until my second year of school. And I think that, with these kind of camps, right, such as Atom Camp, they can frequently operate on a very accelerated schedule. And sometimes people may come out of this with this kind of concern of, oh my gosh, I still don't know if I'm a real expert or not. My expertise, at least, was built through a lot of trial and error, trying to solve problems that I found personally impactful, such as the summarization work that I've talked about. So that's kind of one kind of my pet interest. I think that the folks in here are interested in a lot of other parts of my background. So I was very fortunate. I got my first internship and first real job at Intel. And a lot of that was based off of my GitHub profile, which wasn't quite as cool as it is today at the time. But American tech companies really like to see people who are doing kind of open source work on their own, and love to see the passion, right? And I mean, I think this is even kind of a stereotype in American culture, right? Americans love to say, instead of something being good, something's awesome, right? So a bit of embellishment potentially sometimes, but eagerness and passion, just again and again, I can't emphasize enough how important that kind of thing is. I have done some work, so pretty much all of my publications are, two of them were about competitive debate. My first one was a data set called DebateSum, which is where I took every piece of evidence in the competitive debate community and gathered it into a huge data set. As an aside, one of the big lessons right now that we're finding in AI and machine learning in general is that probably the single most important factor in good quality models is good quality data sets. And data set creation is a challenging task, mainly because for a lot of people, they have to rely on things like human annotators or other kind of techniques that don't necessarily scale. I'm lucky that competitive debaters were unknowingly my annotators, and that they had a project to open source their evidence that has been going on for about 20 years now, and that project was not known to anybody else in the NLP community. So I sort of swooped in, created the data set from all the Word documents that they had been contributing for 20 years, and then got my paper published about that. So that was in 2020. That was my first ever paper. And as an aside, by the way, I only have a bachelor's degree. So I think that there's a lot of people that kind of look at this like publishing in the academic world as something only for grad students or professors. That's not a requirement. Nobody asks you what your academic background is. I mean, goodness, a 15-year-old could send a paper to any of these places, and if it passed peer review, they're invited to come and talk. So don't let a lack of credentials stop you from trying your best and trying to make an impact anywhere that you sort of are interested in. This field of software engineering is one that really respects self-teaching, self-learning, and it's sort of anti-credentialism and elitism, right? I mean, this is why we do all the programming tests and stuff whenever there's hiring, right? Rather than just always accepting, somebody's competent because they have X number of years of experience. So my second paper that got accepted at a major conference came 2 years later on a totally different NLP topic. This paper is called "Most Language Models Can Be Poets Too: A Constrained Text Generation Studio." So I'm going to link the repo for that, which also has links to the paper and everything. And this this work actually came because my stepdad has a book on his shelf called Gadsby, and I'm going to link it. It's not Gatsby like the Great Gatsby. Gadsby, Gadsby. I'm going to link a article about this. And it is a relatively unknown novel written in 1939, and what's special about it is that it's 50,000 word novel without the letter E being used. And of course, you know, for you all here know English and know that the letter E is, I believe, the most popular and most highly used letter in the language. I believe that a solid 25%, or maybe it's even 30% of all words include it. And beyond that, I saw this book and I'm reading it and I'm like, what about language model? Can language models do this? And so I was doing my work shortly before ChatGPT had come out. I want to acknowledge right now that if you ask ChatGPT in the prompt to write you like a long paragraph of valid English where it doesn't use the letter E in any of the words, it may sometimes do it correctly, but frequently it fails at following even that one constraint. And if you ask it to do multiple constraints simultaneously, an example, don't use the letter E and then put the letter A in, and always use the letter A in words, it will completely fail. And the reason for that failure is not, I kind of study the reason in the paper, but it's due to the tokenization scheme. And tokenization referring to how we convert from the actual English into a numerical representation that a computer can reason about. The way that language models operate is that they have a very limited vocabulary, actually, a vocabulary of only, in the case of GPT-3, 4, ChatGPT, etc., of about 50,000 words. Or sorry, 50,000 tokens, where a token is usually a subword. So language models essentially sound out words that they've never seen before and deduce their meaning in terms of their understanding of the meanings of subwords. And so a subword could be, you know, like a prefix or a suffix, but usually they don't map so nicely into kind of linguistic notions of subwords. And tokenization is a rather, you know, the way we currently do it is very useful for a lot, including being able to have language models deduce meanings of words they've never seen, or even to imagine new words. But this current style, and by the way, the style that most used today is called byte pair encoding, if you want to research more about it. And I'm also going to link an article from a researcher I'm very much a fan of, named Gwern, who talks about issues with tokenization in the context of creative writing. I'm also cited in this little blurb, but I think he does a better explanation than myself of sort of the role of tokenization in problems with language models. So and this tokenization issue is also why language models struggle at math, because they tokenize numbers, like large numbers, like millions or more, in terms of smaller numbers. And so this is why you can't rely on a language model to perform arithmetic correctly without usage of a tool, right, like a calculator. But so all of this and combined led me to be, you know, struggling with this idea that language models can't follow simple syntactic, semantic, or phonetic constraints. I also observed that rhyming remains difficult for language models. In particular, ChatGPT, if you ask it to write everything where it rhymes, once in a while it will make mistakes, or it will, and especially if you try to ask it to rhyme while simultaneously not using the letter E. So I was looking at all of this, and I'm sitting here being like, wait a moment, there's got to be a way to force a language model to follow these constraints. Because the traditional way that people kind of change the behavior of a language model is a concept called fine-tuning, which is where you just continue to kind of perform the same training regimen as before, but on a different set of data tailored to your particular task. But fine-tuning, even to the point of absurdity, right? Overtraining a model doesn't guarantee that it will follow these kind of constraints. You might be able to get it where it follows them in 99% of cases, but not 100%. So I had an idea that I think is simple enough that frankly, I can't even believe it got published. The idea is, why don't we just filter everything out of the language model's vocabulary before we sample one of these tokens and generate text? And so let me back up. For those who might not understand how language models are actually generating their text, they're generating it one subword at a time. So they take the previous, the context, your input query, as well as the output that's already been generated, and then calculates a probability distribution of what the most likely next token continuation is over its entire vocabulary. And it performs this, you know, if you're generating a paragraph, it may do that operation 100 or more times, you know, however many times it needs to generate your completion. So I say, wait a moment, we can just filter, right? We can say, all right, if a word in the or subword in the vocabulary has the letter E in it, just set the probability of generating to 0. And it's a ridiculously simple technique. In fact, the ability to ban tokens has been exposed in language models, including ChatGPT. But the way that you do it is by passing it a list of banned tokens. So you, in fact, have to calculate what those tokens are yourself. There's a function for that, but it's something that people don't necessarily know about very well. And then the type of constraints I'm interested in usually ban over 30% of the vocabulary at once. And there's no easy way, even today, using any models, with the exception of my constraint text generation studio, to kind of do that. So so that was kind of the motivation for me. And so that work on most language models can be poets, and the constraint text gen studio is where I create kind of a way for creative writers to leverage language models with all the constraints that they might want. So say, okay, I want my word to be no more than 5 letters, right? And if a word would be generated with more than 5 letters, just don't allow it to be generated. And a wide variety of these kind of constraints. So I'm really proud of this work. I can tell you that, so I presented it at a conference called CoLing, the International Conference on Computational Linguistics, and it got, it kind of bemused the people there, right? I think it was most of the people who kind of publish papers in this world, they tend to publish papers where they show, hey, we have a new method that slightly outperforms the previous state-of-the-art baseline by 3 to 5%, and then kind of going into details about that outperforming some baseline. Whereas my work, there was no data sets before my work at all. Like nobody had prepared, a large text without the letter E in it. So the first thing in that paper I actually contributed is a data set of all the books in English I could find that didn't have the letter E in it. And I found 3.5 books. And the reason I say a half is that one of those books is called Eunoia, E-U-N-O-I-A. Note that every vowel except the letter Y is in that word Eunoia. And in that book, each chapter only uses one of the vowels. So there's a chapter in there, the longest, which only uses the letter E for the vowel. And of course, we have to omit that large chapter from this book because it violates the constraint. So So the data set's called lipogram E. Lipogram is the English term for banning a particular letter, like the technical term, and for writings that do that. And then after I have that data set, I show that fine-tuning models on it doesn't make them stop using the letter E, and then I show that my technique works 100% of the time. And what's cool about it is that in the context of trying to avoid errors, right, it also strictly improves model performance in this one, task. Though I want to also observe that there's kind of a sinister side of this paper as well, and one that I only mused about a little bit at the time, but is in retrospect extremely important, and I've had a lot of people contact me about it, sometimes from scary communities, right? And you'll understand what I mean in a moment. Banning large numbers of tokens from a language model's vocabulary can have a lot of negative effects because language models, the way that they sample the next token from their whole vocabulary, right? There's this notion of greedy sampling, which is where you just always take the most likely continuation, the very top of the distribution. But it's found empirically that this leads to less creative writing. And so techniques have been, techniques have been pioneered that kind of say, hey, what if we sample from like the top 10 or the top 20 tokens, and then maybe do like a weighted sampling where things near the top of that are more likely to be sampled, but once in a while we let the model sample the 10th or 20th most likely continuation. That's cool, and most of those techniques for sampling are known by things like top P, top K, or nucleus sampling for those who want to research them. They're ubiquitous. I think ChatGPT is using top P and top K sampling, and the temperature parameter in language models is about how likely a language model is to sample from a less likely part of the probability distribution. So as you increase the temperature, the model is more willing to get unhinged, but also more willing to be creative. The problem, though, so going back to the problem with banning large numbers of tokens, is that you force the model to be in low probability, parts of its distribution, and that means that now the model could get offensive, or the model could start generating things unrelated to your task, like computer code or gibberish. I saw a lot of gibberish, especially because I had been studying this before ChatGPT came out, mostly on GPT-2, which is already not a great model, already prone to gibberish even without messing with the vocabulary. But the scariest part is the idea that you can attack language models really easily. So an example of this is if you ask most language models today to generate something that looks like social security number, or which in America is a really, really important personal information that you use to, among other things, claim your retirement money, and is used for identification. ChatGPT will just say, "Oh, I'm sorry, I can't do that." But let me ask you, what happens if you ban every single token except numbers and hyphens? And numbers and hyphens are what are used in social security numbers. I can tell you that now language models, even those that are aligned against doing bad things, will be forced to generate what appears to be social security numbers. So I mused for about a paragraph in the paper and talked about how if you know what you want a language, like if you know that something is in a language model that you want it to leak, and you know what isn't in it, you just ban everything that isn't in whatever you're trying to get it to leak. So, and I encourage those to, who are curious about this, you can test that idea using Constrained Text Generation Studio. I would recommend trying it on a open sourced model such as Intel's Neural Chat's a really good one. That's 7 billion parameters. But But so yeah, that was my second work, my second paper. That and again, that all just came from a book on my stepdad's shelf that I just like saw one day, and the idea came to me. So ideas are like that. And further, this was something where I had expected the NLP community to have done a bunch of prior work on this, but I honestly could find almost nothing. And the fact that they accepted it and published it with me basically saying that implies that at least my peer review, the people who peer reviewed it agreed that there was almost no work. So I think that a lot of people don't necessarily realize how low-hanging the low-hanging fruit is in some cases. I think that there's lots of things that academics ignore or are just not aware of. And I'll point, I'm not unfortunately familiar with languages in Pakistan or India, but if work such as what I'm describing was available in English to be done, I'm sure that enormous amounts of work that should be done are totally like not done, are ready for interested, passionate folks to start studying, who speak the languages of Pakistan or India or Afghanistan or places in that region. And in fact, that's been one of the great complaints in the world of NLP, has been the lack of study in languages outside of English and Chinese. So there's a great deal of desire right now for people to kind of do that work and showcase it.
Alan, thank you. Thank you so much. I am, as much as I'm enjoying the insights and all the cool things that you're sharing, I'm sure these are super helpful, but I'd also like to bring your attention that these are also students, and they're all, some are learning data science, some are in AI and all the latest advancements in AI and generative models, NLP as well. So I would really request you to please talk a little about what are the skills and things that these people should learn and get into as well, like provide a sort of a roadmap with all the recent advancement, and especially because you work in NLP and also generative models. Could you please tell us a little about how these people should, what are the skills that they should pursue, what is their, what are the tools they need to look into and learn? If you could please talk a little about that as well.
Yeah, that sounds good. The very first thing, and I'm sure that that's what you've already been working on or will work on at Atom Camp, is Python. Python is the language of AI and data science, and all attempts to sort of use some other language have basically failed. And there's so much inertia that it will continue to be that way. So Python proficiency is a must. We're lucky now that ChatGPT has become good enough that if you've got questions and you're struggling to Google it, a lot of times you can get some quick help. As far as other skills, a lot of people who get asked how they can break into machine learning or data science, they get told to study a lot of math. And math, of course, is very important, but they frequently push too hard on subfields of math that are not that useful for people unless they're doing very advanced things. So calculus is, in my opinion, essentially unnecessary unless you're going to focus on gradient descent or related things. And if you don't know what that is, then you don't need it. What I would really recommend is to take as much statistics or learning about statistics as you can. Ultimately, all of what machine learning and AI is very sophisticated, advanced statistics, including transformer models. Sometimes I hear people claim that those aren't statistical, but they are. And then the other subfield of math that I would say is important, but isn't quite as important as statistics, is linear algebra. The study of matrices and vectors. Most of the mathematical encodings that we use for language for generative AI are lists of numbers, and we call a list of numbers a vector. So those are the two kind of subfields of math. It's really nice to kind of have historical understandings of what's going on, but I would actually pressure people to not get lost in the weeds of trying to read papers even 3 to 5 years old, because frequently things have sort of superseded those techniques. So I'll move more towards the kind of technologies within the data science and AI that I think are really impactful and important to know about right now. Nearly all state-of-the-art models today are built using a framework called PyTorch. PyTorch is created by Facebook. It's the main competitor to TensorFlow from Google. PyTorch and TensorFlow have been sort of in a war for users since they were created. PyTorch has now essentially won victory, with probably 90% or more of projects being built on top of it. PyTorch allows you to program your GPU to be able to, perform operations that would normally be performed on your CPU. And programming for a GPU is very difficult. Writing code directly in CUDA, sorry, let me back up. Behind the scenes, PyTorch converts all of the code you write in it into CUDA code. CUDA is the language from NVIDIA that allows you, operating on its GPUs. So PyTorch is a kind of a wrapper and a convenience tool to have access to be able to perform any operation you want on any device. So for example, if you don't have a GPU and you run some PyTorch code, it will run on your CPU instead. PyTorch is, even for me, sometimes difficult, and even for its greatest experts can still be challenging just by the nature of the task. I'll also say that learning PyTorch beyond the basics is probably not super important unless you're working on developing models, which many people aren't. The next skill I would talk about is learning Python's package management system. And the reason for this is that most of what people such as yourselves will want to do is take a cool state-of-the-art technique and run it on your own computer and play with it, right? That's what we want to do. For example, generative art. And a lot of times, the kind of barrier is installing these packages. Contrary to most assumptions that people might make about code quality being high or AI programmers being good at programming, it's actually the opposite. AI developers are pathetic at writing code and are probably some of the worst programmers you'll ever find, at least in terms of writing code that can be easily installed and that follows traditional software engineering practices. So what many people will find is that they'll install maybe one of these state-of-the-art libraries, such as Stable Diffusion, and then they'll try to install a second thing, and then they'll just break their whole Python environment. So I actually just saw a comment that says make an env and put all in it. Yeah, that's essentially one of the kind of ways that you handle this problem, by having separate Python environments. But the core concepts of package management in Python, using its default package manager pip, or alternative package managers such as Anaconda, that's very important to learn. And in fact, Anaconda and Conda is the whole point. So let me back up. Python's default package manager pip, when you install things, it won't, if you install a new package, it won't guarantee that the environment doesn't break your previous stuff at the end, right? It just installs things, and frequently it will update packages that had to be set at a very specific version, and that's a problem. So Anaconda, this alternative package manager, kind of guarantees when it installs something that everything else will continue to work. And if it can't find a path to do that, it will just tell you, sorry, make a new environment. That's extremely important, and you'll find that even very deeply experienced PhDs will have day-long headaches of fighting Python's package manager, because it's the worst part of Python. I think every developer will agree it sucks. And package management in other languages is superior. As far as further skills, there's a term that is somewhat controversial, prompt engineering. You might see a lot of people on the internet claiming prompt engineering is not real, or even if it is, it's going to be a dead skill in 2 to 3 years. I vehemently disagree with this interpretation for a few reasons. One of them is that prompt engineering is frequently mentioned as being prompt crafting, right? Just like writing really sophisticated prompts for AI models. This is not the case at all. Real prompt engineering involves applying engineering principles, such as techniques that can't be performed by just writing in natural language itself. So I will talk a little bit about AI art for a moment, because for any of you who have played with Stable Diffusion, you might have noticed that you can upweight or downweight particular tokens. So an example is, you say, I want to generate a blue painting of Barack Obama, right? You just write that query, blue painting Barack Obama. Frequently, it will still not generate a blue painting, right? Or if it does, it might not be blue enough for you. So you can simply upweight the token blue to be like 150% as strong as it previously was, and then you get correspondingly more blue images. You might notice that such a technique is not available to you in ChatGPT or really any other NLP model. I have no idea why this is. I've actually demonstrated that such similar upweighting is available, or at least possible, in these models, and I've kind of complained on some blog posts on my GitHub about this. But all of this to say that upweighting or downweighting tokens, or the other myriad kind of techniques for engineering a prompt, are powerful, and they will not go away even as AI gets better, mainly because the amount of control and creativity available to you goes way up as a result of having access to these techniques. I'll further just talk about how even techniques that I would call maybe just really sophisticated prompt crafting and not necessarily engineering are still very important. Examples of this would be, there's a term called chain of thought, where you basically ask a language model to think about what it's going to do and before it does something, and that tends to improve the performance on models very much. So prompt engineering and prompt crafting are very important skills, and they're very much emerging skills. So an example, and this is the techniques that we have to improve models are ridiculous, right? So an example is asking ChatGPT, telling it, oh, you're a master of whatever I'm asking it to do. You're the best in the world, right? Gussing it up makes the models better. Correspondingly, threatening the model, telling it, I'm going to get fired if you don't get this right, also improves performance. There's even work that shows that writing your prompt, or the important part, in all caps, will improve the model's ability to follow instructions. So yeah, I see all the laughing emojis. I feel the same way when I'm reading some of this, stuff, but it really does work, at least on current models. As far as further skills in the Gen AI world, I'm going to use the term hyperparameters. So that's a long word. It basically means settings. So a Yeah, all cap shouting, yes. So settings on models. So I talked a little bit about this like temperature parameter earlier. And that is known as a hyperparameter when it's a setting for a machine learning model. Whenever you have a model, they will have dozens, usually, of settings that control the way that the model operates and how it generates things. Detailed knowledge of what these settings mean and what they do is so important to get the best performance out of your models. And a lot of times the developers of the tools that you're using don't necessarily document everything super well. They might assume that the people using the stuff are as experienced as they are, and frequently that's not the case. So I encourage you always, whenever you find one of these settings on a model and you're not sure of what it's doing, don't just let yourself stay ignorant. Google it, search up and figure out what is it specifically doing. The next skill I'll talk about is, I'll call it, I don't actually know what to call this, but what I would say is choosing good tools. And what I mean by this is that there are many competing frameworks for running generative AI. So an example, running like most NLP models, but also stable diffusion models, are hosted on a model hub called Hugging Face. Hugging Face is the real OpenAI because the company OpenAI does not open source nearly anything and would probably be better named closed AI. But Hugging Face, with its rather strange name, has sort of taken up this banner of truly open sourced AI for a while now, and has hundreds of thousands of models you can run for free. However, running them through Hugging Face, it's done all in code, but for a lot of models, particularly for generative art, you want like a visual, like graphical user interface. And so I'm gonna link some examples of user interfaces that make running generative art far better, right? They give you a massive amount of tools on top of, in this case, Stable Diffusion, the AI art generator, to give you control and easily access every single little sub-bit of Stable Diffusion's power, as well as access to literally thousands of custom extensions from the community that can, do everything from personalized text to video to, simple things like automatically, enhancing the prompt that you just wrote. So I'm going to link 2 projects that I'll talk about briefly that I highly recommend folks to kind of check out in this space. The first one is called Automatic 1111. That's the name of the author. And despite its rather strange name, it has 115 or 114,000 GitHub stars, which is probably the most GitHub stars I've ever seen on any project, right? So that shows you how beloved and powerful it is. There's a competitor to it called Comfy UI. Comfy UI implements a style of development called like a node-based editor, which is like visual programming. If for anybody who's used Blender or animation tools, you'll feel right at home to the interface of Comfy UI. And for those who haven't, you can essentially write a pipeline to generate an image in terms of like building blocks, almost like Legos. So both of these tools are for running Stable Diffusion and can be, kind of complement each other. And in fact, this is an example where I talk about package management. So I really recommend that if you're going to install these, that you have a separate environment for Automatic 1111 and a different environment for Comfy UI. You'll thank me later for doing that. I'll talk just a little more about Automatic. Automatic is, the way it works is that it creates a web user interface. And the point of that is that you can run it on your personal machine and then you can share it either over your local network. If you're at home, maybe you're sitting on your bed with your phone connected to your personal Wi-Fi, and you want to generate some art, but you don't want to get up and go to your computer. Well, you can just share your instance on your network and then connect to whatever the IP address is of your personal computer, and then you start generating art. Or you can expose it to the full open internet, put a username and password on if you're going to do this. That there's a setting to enable that, because you don't want to expose your thing to the open internet without a password. You have no idea who's searching for unsecured instances of this running and what they might do with it. And then the next kind of closely related knowledge beyond just sort of knowing what the right user interface is for the job. And actually, while I'm thinking about, there's an equivalent user interface to Automatic for language models called Uba Booga, which is very powerful for playing with open source language models. I'm going to link that as well. Again, also put that in a separate environment if you're going to install all three of these. And then the next related thing is to know where to get models. So I already talked about Hugging Face. However, if you are interested in AI art, there's a kind of a separate website called civet.ai. I'll link civet.ai real quick as well. And this is the de facto hub of pretty much all AI art. However, a warning about Civet AI, especially once you log into the website, the community there seems to be very, they really like anime, and they really like, I don't know how else to say it, but a lot of the people there are generating things that are not safe for work. So you have to log into the website and kind of turn on or kind of disable the secure the safe for work filters and stuff. Even without that, some of the models can be pretty obviously made by people who had not necessarily good intentions with what they're doing. That being said, there's still hundreds of thousands of powerful, awesome models there, for art styles, for, like famous celebrities, or for concepts. And amazing work being produced there every day. I'll also further talk a little bit about the ethics side while I'm at it. This technology is insanely powerful, right? And there's all sorts of abuse potential with language models, and to a greater extent with diffusion models. With that, we sort of have a responsibility as practitioners and users of these models to highlight ethical problems and to try to prevent them. If, and I mean, forget whatever ethical reasons to be ethical. If we don't, if unethical uses of these models become well known to lawmakers, policymakers, they'll start to regulate it, right? And I'm not very familiar with the politics of Pakistan, but I'm sure that the government there could, if they found people doing things that they didn't like with it, could be very restrictive and make it very difficult for people to even access some of these websites to use these models. I realize we're getting near the end of the time, so I could probably keep talking forever, but I'd love to sort of answer any questions. Real quick, I saw somebody mention VS Code as an alternative to Anaconda, and then is it better to work with VS Code for Python notebooks? VS Code is a integrated development environment, or code editor would be the other term for that. I have not extensively used, VS Code may have some kind of stuff around package management in Python, but I don't use that part of it, and so I'm not aware of it per se, so I don't believe that it's an alternative to Anaconda, but I'm not confident in that answer. And then I also see a question about PyCharm. PyCharm is like a competitor to VS Code, and while we're talking about it, I really encourage people who are learning to program to use the best tools they can. You don't want to be coding in Notepad. You want tools that help like autocomplete for you. So VS Code or PyCharm or any other competitor tool, I highly encourage you to install and write your code in there. And then I heard a discussion about Python notebooks. So Python notebooks, mostly, you might know them if you've used Google Colab. That's an implementation of a technique called literate programming, which is where you kind of interweave like Markdown or English alongside code. And it's supposed to be analogous to like a real scientific notebook. I'm not really personally a fan of editing notebooks within VS Code. I actually run Jupyter Notebook either through my terminal or just use Google Colab personally. But this stuff, like these kind of questions are kind of opinions too. So if you do find that you really like the notebook editing functionality in VS Code, I mean, by all means, use it. So, but my opinion is I don't. I'd love to take any more questions. I'm fine even if somebody wants to ask them verbally.
Anyone has any question that you guys would like to ask before we wrap up? You can just raise your hand or, go ahead.
I can also stay on a bit longer.
Yeah. I see a hand raised. And I also see a question. Do you accept students for AI research?
So you all probably didn't know, but my employer is going through some turmoil actually right now, and as a result, we're not hiring at the moment, but other major companies, including ones that I've used to work at, like Oracle and Intel, are absolutely hiring for like internship positions for AI research and related. What I really encourage, and I'll talk about this just for a moment, when you're looking for a job, apply everywhere. Even if you see that you don't fall, almost nobody fits all the requirements in a job description to the T, and frequently people don't, are missing over half of the things. But I really encourage people to send as many applications out as they can, and more chances are always better. And further, some of those major companies, such as like Intel and Apple, if you're looking for jobs in America, a lot of them can do like visa sponsorship. So unfortunately, it's become even harder to kind of immigrate or be able to get those kind of work authorizations over time. But, always keep trying. And then I saw another question about like companies, firms that offer virtual. When they say virtual, I'm guessing you're referring to remote internships to international students. I already talked about Intel and Apple in terms of like large numbers of H-1Bs, but the FANG companies, Facebook, Apple, Amazon, Netflix, Google, the management consulting firms, McKinsey, Bain and Company, Ernst and Young, and I'm forgetting the fourth one's name, but they're called the Big Four Consulting in America. There's finance, fintech, Bloomberg, Goldman Sachs. There's two more there that I'm forgetting as well. Dang it. Those large companies are great. There's also big companies. So like any Fortune 500 company, Coke, Pepsi, Nike, they're all, looking for AI talent right now. And even companies that have nothing to do with AI, at least ostensibly, like need AI, right? An example for Coke, they probably want to generate art for Coke cans. And they probably don't have a lot of talent even right now for that. And my guess is that Coke probably hires some small AI art company to start experimenting with that. Finally, I'll mention that small and medium-sized startups are frequently hungry for talent and may not necessarily be able to pay a Google engineer's salary, and as such would be very interested in bright folks who are newer to the industry. I'm happy to stay on as long as you'd like, but I see we are a minute over. So
yeah. Thank you so much, Alan. I was just about to say that you committed for an hour, and we're really, really thankful to you and all the insights that you've shared. We're just going to take one last question Taha wanted to ask, and then we're just going to quickly wrap up because it's quite early in the day as well for you. So we're just going to wrap up. Taha, would you like to go, please, and ask your question? Please go ahead. We can't hear you. We can still not hear you. Okay.
Basically, I would like to ask a question related to the future of LLMs. You talked a great deal about the shortcomings and a bit of disadvantages we right now have regarding the LLMs. I recently read a paper regarding a small language models. Could you highlight a few points regarding the future of LLMs and how small language models are going to go in the future?
Yeah, big models. So first of all, there are some people that believe that the future is nearly all small models, and I think that I want to just observe first that as you increase the size and sophistication of models, you get exponential increases in capabilities. So ChatGPT 4 is remarkably more powerful than GPT 3.5, at least on some of the things I've tested it on. And GPT 3.5 is ridiculously better than even GPT 3. So I tend to think that, at least in the so-called search for artificial general intelligence, it's going to be a massive model, trained on the largest amount of data with the most parameters it can fit. That being said, small models that can run on your phone or on your computer are increasingly catching up. And a lot of this is because the overwhelming majority of language models are extremely undertrained, and meaning that they could be trained for far longer on far more text without kind of hitting the maximum representational capacity that they have. Which is to say, most models have far too many parameters compared to what they need. And that's why there are so many good quality 7 billion parameter models today that are coming out that are claiming to rival GPT 3.5. So I think that personal usage of these models will probably, of small models, will continue to proliferate. But at the top of the AI research world, I do believe that the majority of research will still be performed on large models. But things are really exciting, and for most personal people, small models are the way to go and what they should look at using.
Thank you so much, Alan. And I think on that note, we'll wrap up. It's pretty late for at the night as well for you guys. And Alan, it's pretty early for you during the day. And I'm so glad that you managed it. And thank you so much for all the insights and all the cool things that you shared with us. We're really, really thankful. I have also shared the links that Alan shared with you guys as well, in case you wanted them. And thank you so much for everyone for their time. And in case you still have any question, you can write to us. And we'll help as much as we can. Thank you so much, Alan. Yeah, I'd like to go and have a wonderful day.
Yeah, no problem. And feel free to connect or message me on LinkedIn. I'm very available, always happy to help.
Thank you so much. That's very, very kind of you. On that note, thank you so much, everyone. Have a great day, night, and whichever time zone you are in. And we'll see you, inshallah, next time. Bye. Allah Hafiz, everyone.